Today we're doing lesson 5.20, module 5, lesson 20, and your learning goal today is to be able to classify two-dimensional figures in a hierarchy based on properties. Okay, so we've learned all about all the polygons, two-dimensional figures that you need to know, and today we're going to talk about how to sort and classify them based in a hierarchy, when we're going to talk about what a hierarchy is, based on their properties. But first, let's talk about the problem of the day. True or false time? Ready? True or false? All trapezoids are quadrilaterals. True. Okay. Because all trapezoids have how many sides? 4 sides. 4, and so that means they're all quadrilaterals. True or false? All parallelograms are rhombuses. False. False. How could we change this statement to make it true? All parallelograms are rhombuses. How might we change it to make it true? Anushka?
All rhombuses are parallel.
Ooh, yeah, we could say all rhombuses are parallelograms. See how if we switch these two words around, then it becomes true? Very good. Okay, true or false? All squares are trapezoids.
False.
False. How could we change that statement to make it true? Alexander? Is that true? Are all trapezoids squares? No. What could we say? Aditya?
You could say all squares are not trapezoids.
Right, we could say no squares are trapezoids. Why not? Talk to your table group. True or false? All rectangles are squares.
False.
How could I make that statement true? Arun?
All squares are rectangles.
All squares are rectangles. Very good. True or false? Rectangles are always parallelograms.
True.
Very good. Okay. Do you see how you have to know what the shape is or what the polygon is and then be able to think about it in a flexible way to answer these questions? Very good. A hierarchy is a system of organization where groups are ranked from greatest or broadest, another word for greatest is most broad, to least, which is like more specific. Okay? So, for example, we have a hierarchy system here at Stockholmeyer. Okay? We say all the people here are at Stockholmeyer. And actually, there's even a category more broad than Stockholmeyer, which would be Cupertino Union School District, right? So Stockholmeyer is in CUSD. So does that mean that all people who go to Cupertino Union School District go to Stockholmeyer? No. But does it mean that everyone who's in the Stockholmeyer, like if I'm a person here in Stockholmeyer, am I also in the Cupertino Union School District?
Yes.
Does that make sense? So which one's a broader category? CUSD or Stockholmeyer?
CUSD.
So CUSD in our hierarchy is greater or more broad, and Stockholmeyer is less and more specific. Does that make sense? Now within Stockholmeyer, we have different grade levels, don't we? We have kindergarten, first grade, second grade, etc. Okay, so I didn't draw them big enough, but let's say there's kindergarten, there's first grade, there's fourth grade, and there's fifth grade. Now, does that mean if I go to Stockholmeyer, if I'm a person at Stockholmeyer, does that mean I'm for sure in fifth grade? No. But if I'm in fifth grade, does that mean I'm at Stockholmeyer? Yes. Does that make sense? Now, within fifth grade, how can I even break that down further?
Classrooms.
By classrooms. I could say you're in room 49, you're in room 50, 51. So this is a hierarchy, going from greater categories to less. Does that make sense?
Yeah.
Okay. Going from broader to more specific. Now that we know what a hierarchy is, how can we organize these words into a hierarchy? We have to go from most broad to most specific. So which word here is the biggest, most broad category? Lakshan?
I think quadrilaterals, because
Everything else is a quadrilateral? So if I write here, quadrilaterals. Okay, let's cross that word out because we're done. Are you sure that one's the most broad, though? Is there anything that could be a bigger category, Alona? Polygons. Because are all quadrilaterals polygons? But are all polygons quadrilaterals? No. Okay. Okay, good. So we're done with those two. Now, inside quadrilaterals, what would come next? Do we have two different kinds of quadrilaterals? We have trapezoids and what? Okay, so let's write that in here. Trapezoids. And we have yeah, so and then in here we have rectangles. Right? And then what about rhombuses? Where should rhombuses go?
It's
In parallelograms, right? Now, sometimes rectangles, oops, I'm going to draw this in a different way. Can rhombuses and rectangles ever overlap?
Yes.
Sorry, I'm going to redo this. Okay, so I have a rectangle, and it's going to overlap with a rhombus, right? What is inside the overlap?
Square.
A square. Okay, does that make sense? And then we have kites. Kites are also parallelograms, and they need to also overlap with, well,
They're not always.
yeah, I guess we could draw it inside the square because a square could be a kite. But are kites always parallelograms? No. Are they always quadrilaterals?
Yes.
So you might want to draw a kite out here. Does that make sense? So sort it for yourself in a way that makes sense. So here you see all the main category you have, the biggest category is quadrilaterals. See that up here? Okay, now within the quadrilaterals, you have parallelograms and trapezoids. Now inside the parallelograms, you have rhombuses and rectangles, and where they overlap is squares. Trapezoids are in a category all by themselves. See that? Okay, so this is one way that one person decided this was a hierarchy way of showing the hierarchy that makes sense to them. Your way might not be this way, but it might be something similar. A rhombus is either sometimes, always, or never a square. Sometimes. Good. I'm just going to write S for sometimes. A parallelogram is sometimes, always, or never a rectangle. So a parallelogram, which is right here, is it always a rectangle or is it only sometimes a rectangle? Here's a parallelogram. Its opposite sides are parallel and congruent. Is that a rectangle? So a parallelogram is sometimes, always, or never a rectangle. Okay. A rhombus is sometimes, always, or never a parallelogram. Always. A trapezoid is sometimes, always, or never a parallelogram. Never. Okay. A square is sometimes, always, or never a rhombus. Sometimes, depending on its angles. If it has 4 90-degree angles, then it's a square is always a rhombus. But a rhombus is sometimes a square. See how you have to read it differently because depending on the order that those words come in, it changes the meaning. Does that make sense? Okay.